Okay, so this lesson has quite a bit to it. It kind of picks up where we left off yesterday with sketching the curves, these trig functions, and it's going to move through the other reference angles that you learned, as well as what you know about sine, cosine, and tangent and other quadrants. And we're going to kind of look at how we can use those reference angles even in the other quadrants. And hopefully it'll just kind of be the hodgepodge of trig today, but it's really the basis of everything that you need to know. So to start with, we have these equations here that we would need to be able to do the graph for. If you remember from yesterday in the video that we talked about, we want to always look at, if it's asking me to sketch, I start with, okay, it says the sine graph, and so I'm going to draw the sine curve. If you also recall, I said, okay, now look for the amplitude, and of course in this case it should be understood that it's 1 and -1. And then we look at the frequency in that pi, and we say, okay, I want to figure out how long it will take for one curve to complete itself. And so I take 2 pi and I divide it by that frequency pi, and I find out that it's 2. So that means that this curve would end at 2, which then means that this spot here halfway would be 1, half again would be, very good, and then so we continue that pattern, 1 half, 2 halves, 3 halves. Then if you take a moment and you examine what this question is really saying, it says that it wants it from -2 to 1. So it really doesn't want this part here to the right of it, and it actually wants something to do with the left, meaning we have to go all the way to -2. Right now it's only going from 0 to 1. So we need to actually extend this graph, and if you think about its pattern, it's going to go down and it's going to come back up in the same way that you see there to the right. So to the left, as we complete this, if we are then 1 half is right here, and it goes to 0, right? 0 halves. This would be -1 half, -2 halves, or -1, -3 halves, and then -4 halves, or -2. And that would complete the graph. And I'm okay, actually, even on your own, if you just scratch off the part that you don't need and just continue on with what you have to have. Let's do one more example, and then we'll move on to the next kind of section with trig functions. So again, we're dealing with the sine curve. So I'm going to draw the sine graph. Again, my amplitude is 1. The period of the function would be 2 pi divided by the frequency. What's the frequency in this case? Hopefully you recognize that when something says x over 4, that is the same thing as saying 1/4 x, and so therefore my frequency is 1/4. We keep, change, and we flip, and so we recognize that this means 8 pi. So this is the entire graph, completed by 8 pi. So halfway would be 4 pi, half again would be 2 pi. 2 pi, 4 pi, 6 pi, right? That's how we would complete that. But once again, when we look at the domain that they're asking for, they only want from 0 to 4 pi, so therefore we don't need this section over here, and that completes that graph. Hopefully that makes sense to you. Okay, now switching gears a little bit, we're still continuing on with our sine, cosine, and tangent, but we need to kind of establish the foundation of what we know. Back in Algebra 2, my guess is your teacher had you learn triangles such as the 30, 60, 90 triangle and the 45, 45, 90 triangle. And I'm not going to take the time today to discover what those are, what those sides are, but actually put them into a table form. Now, if you had Mrs. Alexander, it's my understanding that she teaches it using this table format, so many of you might remember it. I don't extend it as far as she does because I want you to use the graph as much as you can, and so I continue with just the table. And the table makes sense in and of itself, and then the graph, you can kind of see its own patterns, so I just isolate the two different things rather than extending this table. But here's basically what you discovered. Remember, and before I get into that, this pi over 6, and I probably won't do this often, is 30 degrees. This is 45 degrees, represents pi over 4, and 60 degrees is pi over 3. Not that I want you to ever remember that, but just because you have a perspective of what those angles actually look like, that might help a little bit. So here's how you complete this chart. Yes, it has to do with these reference angles. Yes, that's where these numbers came from. But let me just show you how to remember how to complete this chart. If you can remember this, it's as easy as 1, 2, 3. Then that should be enough to get you through this, because that's exactly how this is. The sine goes first, and it goes 1, 2, 3 right across the top. Everybody gets a hat, meaning a square root sign, and everybody gets divided by 2. Now there are some simplifications that can occur here, and I'm going to just pause for a moment and do that. The square root of 1 is 1, so we don't usually put the hat on that one because that's just 1/2. It's kind of understood. Something as a side note, you might sometimes see pi over 4 written as 1 over the square root of 2. Now I don't want you to memorize that as root 2 over 2 in this chart because it makes it flow nicely. But the 1 over root 2 comes from a rationalized denominator, and that's why you get root 2 over 2. So just to throw that out there, if you see 1 over root 2, don't let that throw you. And occasionally I'll remind you of that as we go through class. All right, back to our table here. So it started with sine 1, 2, 3. Cosine on the opposite side of things goes 3, 2, 1. Everybody gets a hat. And just as I explained in the previous thing, square root of 1 is 1, so I'm not going to put it on that one. Everybody gets divided by 2. And just like in the pi over 4, this is the same thing as 1 over root 2 as well. Now, tangent, if you recall, is sine over cosine. And so that means that what I have is sine over cosine. So that would mean I have 1/2 divided by root 3 over 2. So we would keep, change, and flip. And when you flip, what you notice is the denominators go away. In fact, what makes this even easier is if you just take the numerators from the sine and the cosine, that gives you tangent. So this would be 1 over 1, or root 2 over root 2, which gives me 1. And this would be the square root of 3 over 1, or the square root of 3. All of that means the same thing. So that's your table. 1, 2, 3, 3, 2, 1, and then just using the numerators. Now some other pieces of knowledge that you definitely should know is about the quadrants in terms of our signs. Hopefully you all remember all students take calculus, and what that represents is that all of them, sine, cosine, and tangent, are all positive. In the second quadrant that you see here where the S is, that means that sine is positive. However, cosine and tangent are both negative. The third quadrant has a T there, which basically is to say that tangent is positive, where that means the sine and the cosine must be negative. And in the last quadrant, the fourth quadrant, we have C. And of course, that means that cosine is the only one that's positive. So that means that sine and tangent are both negative. Now that becomes helpful as we're going through this, and I just want to make sure that we're very clear about this. These are two things that you definitely want to memorize. Using this chart, it's quite simple. So if I said to you, I want the cosine of pi over 3, the way that I do that is I basically look in the cosine column, I look at pi over 3 and where they meet, and that gives me 1/2. If I asked you for the tangent of pi over 4, in a similar fashion, we look in the tangent column, I look at the pi over 4, and I see where they meet, and that tells me that it's 1. You'll notice that we'll eventually add to that the quadrants, and so it helps to understand that we can ask pi over 3 angles that are in the second quadrant, or the third quadrant, or the fourth quadrant for that matter. And how that basically shows up is it is a cycle. If you remember, these are cyclical. If we're looking at the sine curve here, you'll notice where pi over 2 falls and where the pi falls, and you can see that this is the sine curve, and sine in the first and second quadrant are positive, just like this graph is revealing, and in the third and fourth it is negative. The similar thing can be shown with cosine as well. So what then would be the other quadrant angles for pi over 4? You're very familiar with how to do it with your reference angles. If I remember right, so if I said that this was 30 degrees, if I wanted to know what's the 30-degree angle here, the way that you did it is you said 180 minus 30, and so that told you that this angle was 150 degrees. And it's similar, we could do it all the way around, but how does that work for radians? Well, we could do something very similar using pi as our 180 and using 2 pi as our 360. But there's actually a neater pattern about this. The cool thing that we started to observe with these angles, and this goes for all of our reference angles here, is that we can actually discover what the second quadrant angle is simply by understanding that if it simplifies, it isn't it. Let me show you what I mean. If I look at 2 pi over 4, hopefully you recognize that as being the same thing as pi over 2. Well, that, of course, is not the second quadrant angle. Actually, that represents 90, or the spot right up here. That's part of the quadrants. The one right in the middle. That's not working for me. So that is not the second quadrant angle. However, 3 pi over 4 would be just another click of 45 degrees, and so it actually does fall in the second quadrant. 4 pi over 4, again, is pi, right? 4 over 4, they divide. And so what we're looking at then is, that's pi, but 5 pi over 4 cannot simplify, and that is the third quadrant angle. In a similar fashion, 6 pi over 4, that's 3 pi over 2. That's how it simplifies. And so that's not the angle, but 7 pi over 4 is the fourth quadrant angle. And that, right there, is giving you your pi over 4 angles. So what that means to me is I can say, okay, I want the sine of 5 pi over 4. And what you're basically saying then is, all right, back to my chart. I'm going to flip back real quick. Sine of pi over 4 is those root 2 over 2 angles. So that means it's a root 2 over 2. Now, we said already that this is the third quadrant angle. What's sine in the third quadrant? Sine is negative. And so the answer to that would have been negative root 2 over 2. Let me just do another one, and then I'll move on to the other quadrant angles. So what I have next, let's say I want the cosine of 3 pi over 4. If I ask for the cosine of 3 pi over 4, once again, we want to go back to cosine, pi over 4 angles. Any of the ones divided by 4, they all fall in this same column. So it is root 2 over 2. 3 pi over 4 is in the second quadrant, and so therefore cosine in the second quadrant is negative, so it also is negative root 2 over 2. All right, now let's pick up with these other quadrants. I'm going to do one more for you, and then I'm going to have you do the next one all on your own for me for the next day for your notes. So pi over 3, let's just try that. 2 pi over 3, does it simplify? No? Good. Then that's your second quadrant angle. 3 pi over 3, of course, that's pi. That's not what we want, and that, of course, is not the angle that we need. So that is not the third quadrant angle. But 4 pi over 3 doesn't simplify, and that would be our third quadrant angle. Lastly is 5 pi over 3, and that does not also simplify. You'll notice that when we go to the next click, or 6 pi over 3, that's 2 pi. We should have had all 4 quadrants by the time we get to 2 pi, or 360 degrees. Does that make sense? I hope so. So now what I'd like you to do for tomorrow's notes, I would like for you to do pi over 6. And I'd like for you to discover what all the quadrants are. We already have the first quadrant. So I would like to know what's the second quadrant angle, the third quadrant pi over 6 angle, and the fourth quadrant pi over 6 angle. Thanks for listening, and be sure to have that done for class.